Hello everyone. We are continuing with the topic of regression, and I have already given you the formulae which are required in the chapter of regression in the first recording of this particular chapter. Okay, so let us follow the problems which are given in our government textbook, exercise 3.2, government textbook, exercise 3.2. Okay, question number 4, exercise 3.2, question number 4. Fine. Now in question number 4, now this particular problem has been asked many times in our state board exams. Okay. So they have given us a table. So we need to write down the values which are given in the table. I hope you all are referring question number 4. Advertisement expenditure is represented by X. So we'll have to write down what is X and Y. So we'll write down X as advertisement expenditure and Y as sales, and the values are in um, rupees. The unit is rupees and the data is in lakhs. Okay, arithmetic mean for both is given. So x bar is 10 and y bar is 90. Arithmetic mean for both x and y they have given, so I have put down the value 10 and 90. Standard deviation is sigma x for x, that is 3, and for y it is sigma y. So standard deviation of y is equal to 12. Correlation coefficient between x and y is 0.8. Okay, so correlation coefficient, it's not covariance, remember that, it's correlation coefficient. So r is equal to 0.8. So this piece of information is given to us. Now first of all they are asking find out the two regression equations. So we'll just calculate both the regression equations. So there are two regression equations, so we'll calculate one by one. First one is line x on y. So this is the first regression equation for line x on y. The equation is x minus x bar bxy, y minus y bar, x minus x bar bxy, y minus y bar. Okay, in this we are having the value of x bar and y bar. We have the values of x bar and y bar. We are supposed to calculate the value of bxy. Okay, now yes, obviously you people are supposed to by heart the formula. You should know by this point that the formula of bxy, bxy is nothing but a regression coefficient of x on y. So the formula of bxy is in terms of r and in terms of covariance. So we'll use the formula which has r. Bxy formula will use the formula which has r because r is given in the problem, that is correlation coefficient. Okay, so r sigma x upon sigma y. Now what is the value of r? The value of r is 0.8. Okay, sigma x and sigma y, we have already written the data, 3 and 4, 12 respectively. Okay, so this is 3 and this is 12, so 0.8 upon 4, which is equal to 0.2. Okay, so this is 0.2. Calculation was pretty simple. Okay, right? So we calculated the value of bxy. Now we'll put in equation number 1. From 1, my next step will be from 1, x minus x bar. X bar is equal to 10. Bxy we just calculated, that is 0.2. Y minus y bar. Y bar is 90. So x minus 10, 0.2 y minus 18. 0.2 into 90. I hope you know how to calculate 0.2 into 90, which will give you 18. X is equal to 0.2 y minus 18 plus 10. So x is equal to minus 0.2 y minus 8. So this is equation of line x on y. Equation of line x on y where x depends on y. So the first line we have already calculated. The first line we have already calculated. Okay, fine. So what we are supposed to do is we are supposed to calculate the second line. So line y on x. Line y on x is nothing but y minus y bar. The equation is y minus y bar by x minus x bar. This is equation number 2. X bar y bar we already have. I've already discussed that. Okay. Byx is equal to covariance between, no, not covariance formula, sorry. We'll use R formula because R is given in the problem. R sigma y upon sigma x. So what is R? R is equal to R is equal to 0.8 given in the problem. Sigma y. Sigma y is 12, sigma x is 3. So 12 upon 3. So 0.8 into 4, which is equal to 3.2. So we got the value of Byx. Okay. We'll put this value of Byx. We'll put this value of Byx in equation number 2 from 2. From 2. Okay. Y minus y bar. Y bar is 90. Byx we just calculated 3.2. X minus x bar. X bar is 10. Okay. So y minus 90. 3.2x minus 3.2 into 10 will give you 32. So y is equal to 3.2x plus 90 minus 32. So y is equal to 3.2x plus 58 plus 90 minus 32. So this is equation of line y on x. Equation of line y on x. Okay, fine. Now second part of the problem is we have calculated both the lines. Second part of the problem is they are asking sales. What are the likely sales? So sales are represented using y. They are asking y. Okay, if advertisement expenditure will be based on advertisement budget. So advertisement budget is nothing but x is equal to rupees 15 lakhs. Okay, so who depends on whom? That is the main question over here. Okay, so who depends on whom? We can very well say that y depends on x over here because y value is not known to us. So we'll write down y depends on x. Use line y on x. Okay, use line y on x. So this is line y on x which I just calculated in the previous part. Y is equal to 3.2x plus 58. Okay, y is equal to 3.2x plus 58. In that you are going to put x as 15. Okay? Put x as 15. So y is equal to 3.2 into 15 plus 58. Okay, 3.2 into 15 plus 58, which is 32 upon 10 into 58. Okay, when I say 32 upon 10, it becomes 16 upon 5. Okay, reducing it with by 2, then 5 ones are 5 threes are. So this will be 48 plus 58. 48 plus 58 is nothing but 106. So sales y is equal to rupees 106, but then we need to put lakhs as well. Okay, sales y is equal to rupees 106 lakhs. Okay, yeah, that was the second part of the problem. Let me take you to the part. Third part of the problem. They're asking what should be the advertisement budget. That means ad budget, advertisement expenditure budget. Those all things are X, right? And they want to achieve a sales target of rupees 120 lakh. So sales is denoted by Y. This should be rupees 120 lakhs. So the main question over here is who depends on whom? That is the main question. So as we can see, X value is not known, so X depends on Y. X depends on Y. Okay, so use line x on y, which already we have calculated. See, line x on y we have already calculated. We'll make use of this. X is equal to 0.2 y minus 8. So x is equal to, put y is equal to 120. Okay. Therefore, x is equal to 0.2 into 120 minus 8, which is 2 upon 10 into, I have just placed wrong bracket over here, sorry. Okay. 120 minus 8, 0 will get cancelled. Okay. 24 minus 8, which is equal to 16. So advertisement budget, okay, which is denoted by x, is equal to rupees 16 lakhs. So this should be your final presentation for this particular question. It's a 4-mark question. Fine. Okay. So that was the end of the fourth problem, which is in exercise 3.2 of your government textbook, right? Now, based on this problem, there are few more problems which you can take it for self-study. I'll give you the problem list. Exercise 3.2, question number 7, question number 8, question number 7, question number 8, then question number 11, and question number 12. 7, 8, 11, 12. These problems you can try. Okay, these all problems are based on exercise 3.2, question number 4, and fourth problem we just solved. Okay, fourth problem we just solved. So for practice, you can solve question number 7, 8, 11, and 12. Okay, so what we'll do is we'll go to the next problem, right? So the next problem over here in this exercise is exercise 3.2, question number 10. Exercise 3.2, question number 10, right? An inquiry of 50 families, go to 3.2, question number 10. An inquiry of 50 families to study the relationship between expenditure on accommodation and expenditure on food and entertainment give the following results. Now n is equal to 50 because the data is gathered for 50 families. Expenditure on accommodation. Okay, I'll be using short forms, but then you're expected to use the full forms in the paper. Expenditure on accommodation is X. Expenditure on food and entertainment is Y. Expenditure on food and entertainment is Y. Okay, we need to write what is X and Y. If it is mentioned in the problem, always mention what is X and Y. Okay, now some other information is also given to us. Summation X, that is the total of the entire X column, 8500. Summation Y, 9600. Okay, sigma X, which is equal to 60. Sigma X is nothing but standard deviation of X. Standard deviation of Y is equal to 20, and R is equal to 0.6. So this information is given to you. Fine. Now using this information, we can first and foremost calculate X bar and Y bar. See, X bar and Y bar are very essential things in statistics. Okay, for our syllabus as well. So summation X is equal to 8500 upon 50. Okay, so X bar is equal to 170. Right. Similarly, Y bar is equal to summation Y upon N, 9600 upon 50. So if you cancel the zeros, it will be 960 upon 5. Okay, 960 upon 5, that will give you 192. You have to divide very clearly. Use of calculators is not allowed. The calculators are not allowed in the exam. So be very much relied on your manual calculations. Practice it well. Don't sit with your calculators while practicing. Okay. So the data is given in this manner. The additional thing which I have written is X bar and Y bar because we know X bar and Y bar are generally required in any problem of statistics. Okay, now we need to read it carefully in the next part, that is estimate as in to find out expenditure on food and entertainment. So expenditure on food and entertainment, that is why this is asked. Find out the expenditure on food and entertainment when expenditure on accommodation, expenditure on accommodation, okay, which is X. Now this X is given as rupees 120. So expenditure on food and accommodation is 120. So mm, on food and entertainment we need to find out, but then expenditure on accommodation is 120. We need to find out why. We need to find out why. So y depends on X, right? Since y is not known, so y depends on X. Use line y on X. Use line y on X. So the equation will be y minus y bar byx x minus x bar. Okay, equation number one. Now see, we know these values x bar, y bar. We have calculated. X we know. The value of x is 120. That also we know. The only thing that we don't know is byx. So we'll first calculate byx. Okay. So byx is equal to r. We'll use the r formula because r is given in the problem. And what is r? R is the correlation coefficient. R is the correlation coefficient. So we will calculate the byx formula using r. Okay. 0.6 sigma y. Sigma y is given in the problem. Very much clear in the problem that sigma y is 20. Sigma x is equal to 60. So this will be 6 upon 10 into 2 by 6. Okay, because these zeros will get cancelled and then 6 also will get cancelled. So this is equal to 0.2. Byx is equal to 0.2. Byx is equal to 0.2. Okay, 2 upon 10. So from 1, we put down all the values. Y minus y bar. Y bar is equal to 192. We just have calculated. See, x bar, y bar 170, 192. So here y bar is equal to 192. Byx we calculated as 0.2. X is 120 and x bar is equal to 170. So y minus y bar. Y bar is 192. 0.2. X is 120. X bar is X is, yes, 120. X bar is 170. Okay. So y minus 192, 2 upon 10, and this will become minus 50. Okay, which is minus 100 upon 10, which is minus 10. Okay, so we are left with y minus 192 is equal to minus 10. Okay, let's write down over here. Y minus 192 is equal to minus 10. Y is equal to 192 minus 10. So y is equal to 182. So expenditure on food and entertainment, okay, is equal to rupees 182. That should be your final answer. Okay, that was question number 10 of exercise 3.2. Question number 10 of exercise 3.2. Yeah, let us go to the same exercise 3.2 of your government textbook, and let us start solving question number 6. So exercise 3.2, question number 6. Two samples of bivariate populations have 15 observations each. So n is equal to 15. It has to be same in both the cases, x and y. Okay, sample means of x and y are 25 and 18 respectively. X bar is equal to 25, y bar is equal to 18, because mean, when we say mean is nothing but average. So x bar and y bar. Mean of x is x bar, mean of y is y bar. The sum of the corresponding sum of the squares of the deviations from the respective means is are 136 and 150. Okay, they have given corresponding sum of squares of deviations. from respective means equal to 136 and 150. 136 and 150, take 150. Okay, so sum, when I say sum, it is nothing but summation squares. So something square. Okay, deviation. Deviation is nothing but difference, which is the minus sign. Difference of what? Difference of x with its respective mean, that is x bar, and difference of y with its respective mean, that is y bar. Okay, sum as in summation, square as in square, deviation is difference. Difference of what? X with its mean, that is x bar, and y with its mean, that is y with y bar. Okay, so this is 136 and 150. I hope you understood the meaning of this line. Corresponding sum of squares of deviations from the respective means is equal to 136 and 150. Fine. So one more line piece of information is given. Sum of product of deviations, okay, from respective means is equal to 123. Take 123. Fine. Okay. So what we'll do is sum is nothing but summation. Product is nothing but multiplication. Sum is summation, product is multiplication. Deviation is minus sign from respective means. Respective means is okay, x bar and y bar, but then deviation of what? Deviation of x with its mean and y with its mean. X with its mean and y with its mean is equal to 123. Sum as in summation, product as in multiplication of what? Of deviation. Deviation matlab, it is minus sign. Okay, it is minus sign. Sum of product of deviation of what? Deviation of x with its mean and y with its mean is equal to 123. So this is the piece of information which is given to us. Fine. Okay, now we are going to see what they are asking. They are asking us line x on y. They are asking us line x on y. So I'll just show you till now what we have written in this problem. Okay, n is given, x bar, y bar is given. Then two lines were given in a very theoretical manner, but then I have interpreted it. Okay, I've interpreted in mathematics. The theoretical part is written in mathematical format or statistical format. Okay, and here as well. So line x on y. Okay, guys. So line x on y. So x minus x bar dxy, y minus y bar. X minus x bar dxy, y minus y bar. Equation number one. Fine. We know what is x bar and y bar. The thing that we don't know is bxy. Now, should we use the formula for r in bxy? Bxy is related to two formulas. Bxy is framed in two different formats. One in terms of r, that is correlation coefficient, and the other is in terms of covariance. But then we cannot use r formula over here, like the previous two problems which I have taken earlier in the lecture. Okay, so we cannot take r formula. We'll have to take covariance formula. So bxy is equal to covariance of xy, okay, upon standard deviation of y square. Equation number two. Okay, equation number two. This formula I had given you earlier. You need to be very clear with the formula list, right? Bxy is equal to covariance of xy upon standard deviation of y square. Okay. Now covariance of xy. Again, there are two formulae. Summation x minus x bar y minus y bar upon n. This is the second formula which I have written first. And there is one more formula, summation xy upon n minus x bar y. Now, certainly we cannot use this formula. The one in blue we cannot use because we are having this data now. Summation x minus x bar y minus y bar. This data we have written in the given part of the problem. Okay, I'll take you back to that slide. See this data we have. So we cannot use the blue colored formula. So this is equal to 123 upon n, and n is equal to 15. Okay, now both are divisible by 3. We can just reduce it and keep it in fraction. So 123 upon n, so that will be 41 upon 5. Okay, and 41 upon 5 is not a very difficult thing to calculate. So this is equal to 41 upon 5. I'll make it 10 down. Hence I'm multiplying and dividing with 2. So 82 upon 10, which is equal to, just a second. Okay, 8.2. Okay, so this is covariance between x and y. Covariance between x and y. Right? Then we are also supposed to calculate the standard deviation of y the whole square. Now, as you recollect in the previous problems, standard deviation we don't calculate directly. We first calculate the variance. So variance of y, once again two formulae are there: y minus y bar the whole square upon n, and summation y square upon n minus y bar square. Now the one which is written in blue I will not apply because my data is in this format: summation y minus y bar the whole square. Okay, so y minus y bar the whole square, that data we have, I'll show you the data. Yes, it is 150. So this is 150 upon 50, that is equal to 10. Okay, now standard deviation of y is equal to square root of variance of y, which is square root of 10. But then we don't require standard deviation precisely, we require its square. We require the square of the standard deviation. So what am I going to do is I'm going to square both the sides. Standard deviation of y square is equal to root of 10 is 10. The square of root of 10 is 10. So we got both variance as well as standard deviation square. Ideally, variance and standard deviation square are one and the same thing, right? So from equation 2, first we'll give importance to equation number 2 and then come back to equation number 1. We have both the values. Which values we have? We have covariance as well as standard deviation of y square. So from 2, bxy is equal to covariance of xy. What is covariance of xy? Covariance of xy we have calculated as 8.2. Okay, and standard deviation of y square was just calculated as 10. Okay, so the answer is 0.82. bxy value is 0.82. Okay, whenever the divisions are quite easy, then only divide, otherwise leave it in fractions. 0.82, right? Now from 1, we'll put all these values in equation number 1. Equation number 1 is nothing but line x on y. X minus x bar. X minus x bar. What is x bar? X bar is equal to 25. Okay, x bar is equal to 25. Okay, then bxy is equal to 0.82. Y minus y bar. What is y bar? Y bar is equal to 18. Now these are simple calculations which we can solve further. Minus 82 into 18. So this is 1664 plus 165, 2 and 8. Okay, so this will be 14.76, 0.82 into 18, and then just add 25 to it, minus 14.76 plus 25. This calculation also will do over here. Okay, 25.00 minus 14.76. So this is 4 This is 2, and then this is 0, and this is 1. So x is equal to 0.82y plus 10.04. This is your equation of line x on y. This is what was required in first place. Okay. So I hope you have understood the solution of this problem as well. Fine. We will proceed with the next question, which is from exercise 3.3 of your government textbook. Exercise 3.3 of your government textbook, and the problem is question number 4. It's question number 4 from exercise 3.3 of your government textbook. Okay. So let us understand what is given. For a bivariate data, bivariate as in two variables, that is x as well as y. Monovariate has only one variable in it. It's a bivariate data, x and y. The regression coefficient of y on x is 0.4. So byx is equal to 0.4. Okay, and then regression coefficient of x on y, that is bxy, is equal to 0.9. Okay, now one thing you remember in the chapter of regression, that is whenever byx and bxy are given to you, it is always good for us to find out r, because it will be somewhere or the other used in the problem. So root of byx into bxy, you can also write root of bxy into byx, that's fine. Okay, so this is root of 0.4 into 0.9, which is 0.36. Fine. R is equal to 36 upon 100. R is equal to 6 upon 10. Okay, so R is equal to positive 0.6. Okay, if you recollect, if byx and bxy both are positive, R value is also positive. Had it been negative, the R final answer will be negative. So we'll write down R is positive since byx, bxy are positive. Byx and bxy are positive. Okay, fine. So we got the value of R. It was not asked, but then we just calculated it. Okay, now one more thing is given. Variance of x in the problem is given. So variance of x is equal to 9. This is given. Now standard deviation of x is equal to root of variance of x, which is root of 9, which is 3. Take a positive value of standard deviation in the entire chapter. Okay. Now they're asking variance of y. Variance of y. We are having two regression coefficients, regression coefficient of y on x and regression coefficient of x and y. Use any one, please use it. So let's take byx. Byx is equal to r sigma y upon sigma x. Okay, so this will give me byx is you know what is byx, it's given in the problem, 0.4. I'll write it as 4 upon 10. Okay, r we calculated, r we just calculated, r is equal to positive 0.6, so I can take positive 6 upon 10, no need to write the positive sign, into sigma y we don't know, and sigma x is equal to 3. So 10 and 10 will get cancelled on both the sides. Okay, 3 ones are 3 twos are. So I'll take this to the next page. 4 is equal to twice sigma y. So sigma y is equal to 4 upon 2, which is equal to 2. Fine. So we got the value of sigma y. Now sigma y is equal to root of variance of y. Therefore 2 is equal to root of variance of y. Squaring both the sides, 2 square is 4, and this is variance of y. This will give me variance of y is equal to 4. And that is what was required in the problem. This is what was required. Okay, fine. Okay, so we'll solve some more examples which are given in our government textbook. Yes, so Uh, Go to miscellaneous exercise. Go to miscellaneous exercise of your government textbook. And in miscellaneous exercise, if you observe, there is question number 4, which has numericals after your true or false. Okay. Question number 4, sub question 8. Question number 4, sub question 8. We are going to solve this right now. Fine. So n is equal to 8. N is equal to 8, and then summation x minus x bar the whole square is equal to 36. Summation y minus y bar the whole square is equal to 44. Okay. Summation of, ignore that I, because I is not required as such in this problem. Summation x minus x bar y minus y bar is equal to 24. Summation x is equal to 32. Summation y is equal to 40. Okay. Let us make it a standard practice to calculate x bar and y bar. So x bar is equal to summation x upon n. Summation x is equal to 32 upon 8, which is 4. X bar is equal to 4. Y bar is equal to 40 upon summation y upon n, which is equal to 40 upon 8. Y bar is equal to 5. So we calculated additionally x bar and y bar, because we know x bar and y bar somewhere or the other it will be used, right? Okay. Now, if you look at the problem, they are asking you line x on y. They are asking you line x on y. Okay. So this was the given data. This, whatever you are saying right now on the slide, it is the given data. Now line x on y. Line x on y we need to calculate. Therefore, x minus x bar dxy, y minus y bar. This is line x on y. We know what is x bar and y bar. X bar, y bar. We know what is x bar and y bar. Okay. Then vxy. Vxy, there are two formulae. One formula has covariance in it, and the other formula has r in it, small r, that is correlation coefficient. So r is not given as such in this problem. There is no value of r which is given. So we use the covariance formula. So covariance between x and y upon standard deviation of y square. Equation number 2. We'll have to go very precisely and stepwise. Okay. Covariance between xy is equal to summation x minus x bar y minus y bar upon n. We also have one more formula, but then we are having the data in the form of x minus x bar y minus y bar. So I'm using this formula for covariance, not the other one. Okay, summation x minus y x bar y minus y bar is equal to 24 upon 8, which is equal to 3, right? 24 upon 8, which is equal to 3. Standard deviation of y square. We'll first calculate the variance of y. Variance of y is equal to summation y minus y bar the whole square upon n. We also have y square upon n minus y bar square, this formula. Okay, for variance, but then I'm not using this because I have the data in the format of y minus y bar the whole square. The chapter is formula based. You should know all the formulae. It's a prerequisite for the all set of problems over here. So this is equal to 44 upon 8. Okay, which is quite not divisible. We'll just write 4 11s and 4 2s, 11 upon 2. Okay. Now standard deviation of y is equal to square root of variance of y, which is root of 11 upon 2. But then we require standard deviation of y square. We require square over here. So what I'm going to do is I'll square both the sides over here. Standard deviation of y the whole square is equal to 11 upon 2. 11 upon 2. Fine. Is it okay? Right. So from 2, first let us take equation number 2. I'll show you equation number 2. Just wait for a while. Yes, so this is equation number 2. We have both the values. We are having both covariance as well as standard deviation of y square. Covariance is 3 and standard deviation of y square is 11 upon 2. So bxy is equal to 3 upon 11 by 2. This 2 will go up in the numerator. Denominator becomes numerator. So this will become 6 upon 11. Okay, fine. So we got bxy. Now let's go back to equation number 1. From 1, this is equation number 1. See that equation number 1. Fine. X minus x bar. X bar we had calculated. I'll show you x bar calculation. See, x bar is 4, y bar is 5. X bar, y bar is very much ready in front of us. X bar is 4, y bar is 5, and bxy is 6 by 11. Okay. Now 6 by 11 calculation is not very easy, so we can just keep it as it is as a fraction. So just cross multiply 6y minus 30. Then when I cross multiplied and 6 I multiplied within the bracket. So 11x is equal to 6y minus 30 plus 44. So 11x is equal to 6y plus 14. This is your line equation of line x on y. Equation of line x on y. Fine. Is it okay? Yeah. Then the 12th problem. In the same miscellaneous exercise, the problem before the activities. Byx is equal to minus 0.6 and bxy is equal to minus 0.216. Okay, we are supposed to find out r. R is equal to root of byx into bxy. Minus 0.6 minus 0.216. So minus into minus will become plus. Okay, and this can be written as 6 upon 10, and the other thing can be written as 216 upon 1000. Okay, and 216 we know, guys. What is 216? 6 into 6. 1000 is 10 into 10 into 10. Okay, so out of this 6, 1 6 will go outside the root. Out of this 2 6, 1 6 will go outside the root. Similar cases with 10. Out of this 2 10, root 1 will go outside the root, and out of this 2 10, 1 will go outside the root. So it will be r is equal to 6 into 6, 10 into 10, which is 36 upon 100. But then r is written as minus 0.36. Now why minus? I'll write down r is negative since byx, bxy are negative. Are you able to understand? Okay, I hope you understood the root calculation as well. Okay, we'll continue with some more problems in the next lecture. Thank you.